Okay, ladies and gentlemen, let's take a look at solving absolute value equations. Just a reminder that the first thing we need to deal with absolute value equations is absolute value takes whatever is inside and it makes it positive. So if I have positive x, I will have positive x. If, on the other hand, I have the absolute value of negative x, my answer will again be positive x because it takes whatever is inside and it turns it positive. So if I have 7, absolute value of 7 is 7. Absolute value of negative 7 is also 7. And the reason for this is because if you look at a number line, if I have 7, 1, 2, 3, 4, 5, 6, 7, it is 7 units away from 0. If, on the other hand, I have negative 7, that means 1, 2, 3, 4, 5, 6, 7. That means I am also 1, 2, 3, 4, 5, 6, 7 units away from the origin that way. So absolute value is nothing but a magnitude, and the magnitude of a particular value. Now, when we go to solving equations, we have something like this. We have an absolute value of x plus 2 equals 5. Well, basically, long story short, if the absolute value of x plus 2 equals 5, that means whatever's inside there has to either be 5, because the absolute value of 5 would be 5, or it has to be negative 5, because the absolute value of negative 5 is also 5. So if this, whatever's here, has to be either 5, why don't we set it equal to that? X plus 2 equals 5. And if everything in here has to equal negative 5, then I can set it equal. X plus 2 equals negative 5. So what I've really done is in every absolute value solving, once you get the absolute value by itself, you break it up such that you have a positive version of the equation, x plus 2 equals positive 5. You have a negative version of the equation, x plus 2 equals negative 5. So with that, then we begin solving. Minus 2, minus 2, minus 2. So x equals negative 7, or x equals 3. Now, the thing is, those are my two solutions because it could be on either direction from whatever it is I'm solving for. Additionally, though, we do need to double check, so let's plug them back in. Negative 7 plus 2, absolute value. Well, that equals the absolute value of negative 5. The absolute value of negative 5 is 5. And does it work? Yes, it does. Check. Okay. Now over here, if I take 3 and I say absolute value of 3 plus 2 equals 5, well, that's absolute value of 5. Absolute value of 5 is 5. I agree. Check. Okay. Now, ladies and gentlemen, when we plug values in, this is called evaluating. So if I wish to evaluate this absolute value, I would simply plug in a value. Okay? Plug in a value, see if it works. Now, that's the basics. Let's do a more complicated example. 3 parenthesis x minus 2 absolute value plus 4 equals 13. Okay, now if I go with something like this, the first thing I do is I cannot break it up into 2 bits yet. I have to get the absolute value by itself. Easiest way to do that, subtract 4 from both sides. 3 parenthesis x minus 2 absolute value equals 9. Now I'm going to divide both sides by 3. Divide both sides by 3. Absolute value of x minus 2 equals 3. So now, once I have the absolute value by itself, I break it up. A negative version, x minus 2 equals negative 3, or x minus 2 could equal positive 3. Okay, and go to town from that. Plus 2, plus 2, plus 2, plus 2. X equals negative 1, or x equals 5. Again, 3 parenthesis negative 1 minus 2 absolute value plus 4 equals 13. That's going to be 3. 3 times 3 plus 4. 3 times 3 plus 4 is 13. It works out. And I plug in the 5 and double check it as well. Now, for graphing these solutions, it's very easy. It says x equals 1, negative 1. So if that's my 0, I go back 1 and put a dot, negative 1. If I go over here, I have x equals 5. I'm going to go 1, 2, 3, 4, 5. Put a dot, and that's 5. So I have now graphed my solutions on a number line. Okay, that's absolute value solving. The biggest thing is you must have both a positive version and a negative version, but you can't do that until you've gotten it by itself.